What we're seeing here is a catheter inside of a vein. These are cross sections, so the vein's coming out towards the screen. You're going up and down a tube. And above it we see the artery, and this is how we see it anatomically in the body. In the back of the vein is going to be only hard structures like the spine, and on top of the vein is an artery, and an artery, when it's pressurized, is pretty stiff. A vein has low pressure in it, so you've got a low pressure floppy thing in between two hard stiff things. So you can easily compress a vein and cause problems. So as we scroll down the image, the aorta, inferior vena cava with the catheter inside, we're now going to see the bifurcation of the aorta. The aorta is now dividing into the left common iliac artery and the right common iliac artery. The inferior vena cava is dividing into the right common iliac vein and left common iliac vein. Now the arteries have split into the right and left. Look at this big vein here, and as we scroll down, look how this thing just gets compressed. Now the vein's about this big, and this is the overlying right common iliac artery compressing the left common iliac vein against the spine. As we keep going south, you see the artery, common iliac artery, starting to separate away, the vein starting to reopen up again, and now we're going to hit a second compression point. Again, this is the left side, so now we're looking at the left common iliac artery on top of the left common iliac vein. The artery is now going to give off the hypogastric artery, and now the hypogastric artery is causing compression at another site of the iliac vein. This compression is not as severe as the first one, but it's just to illustrate the point that there's 4 sites of compression that can occur, both common iliac veins and both external iliac veins. This is a guide wire inside of the vein. This is a fluoro image now with only x-rays. It's not ultrasound. This is the spine, the spinal column going straight up and down. And at the lumbar 4, lumbar 5 interface is where the iliac vein divides, and here you see a balloon at that L4, L5 space, and you see a waist in the balloon. That means as the balloon is expanding, it's being constrained by that iliac vein compression site. And as we blow it up to 2 atmospheres, it's going to spring open that area of compression. If you balloon only, the lesion will recur. So what we do then is we stent it. This is the wire. You do everything over a guide wire. This is a stainless steel stent that's been deployed in the vein. What we've learned through the clinical studies, mostly from the Raju Negulin group, is that you want to have the proximal stent extending about 1 centimeter into the inferior vena cava. It's counterintuitive, but that's what the data show. The stent patency is better if you extend it into the inferior vena cava. So that's what we did in this case. This is back to the intravascular ultrasound image. This is the inferior vena cava. It's big, and the stent is a round circle here. You can see that the stent does not reach the other wall. That means that it's just extending into the inferior vena cava without completely blocking the other side, so we're not jailing the right common iliac vein. And as we go down, now we're in the area where the lesion was. So this was the left common iliac vein compression site. You can see where we saw earlier the division of the artery, so the left common iliac artery and the right common iliac artery. This was compressing the vein closed, and now it has a metal stent completely opposed to the wall of the vein. The vein's big and round now. It's no longer compressed. And this is the one that most people know about, the right common iliac artery crossing the left common iliac vein. The one that people don't know about are the other 3 compression points that can occur. The point is there's 4 sites of compression that are common and unknown to most physicians. Most doctors know about the single lesion right there.